Okay, welcome back to another video on the Maths channel. It's your teacher Miss Lim here, and in this video we're going to be looking at finding the rule using a table of values. So by the end of this lesson you'll be able to find a rule from a table of values, from a graph, and from pictorial patterns. So let's have a look at the first part of this lesson, finding the rule from a table of values. I want you to have a look at these table of values and their rules and see if you can find a pattern for each of these. So for question A, we've got y equals minus 2x plus 1, and its table of values below it. And for question B, we have y equals half x minus 2, and its associated table of values below that. Pause the video, see if we can find a pattern for both of these. Okay, let's have a look at question A. I'm having a look at this, and I can see that as the x values go up 1, these keep going up 1, the y values are going down 2. Okay, so the pattern is as x increases by 1, y decreases by 2. What about B? We can see as x increases by 1 each time, what's happening to y? It looks like it's increasing by half. It's going up by half. So my question to you is, why do you think these are the particular patterns? Let's have a look at A. Why do you think that the pattern is that it's going up, it's going down by 2? Okay, a negative means it's going down. It's going down by 2. Can you see anywhere in the rule that might suggest that the pattern will go down by 2? Or what about question B? The pattern here is it's going up by 5. It's positive. It's going up by 5. Sorry, not 5, by half. Can you suggest anywhere in this rule that might suggest that it's always going to go up by half? Well, if you said, oh, the coefficient of x here is minus 2, and that's why the pattern is that it's going to go down by 2 each time, or that the coefficient of x here is half, positive half, which means that the pattern is going to go up by half, then you'd be correct. Okay, so depending on the pattern, that tells us what the coefficient of x will be, the number in front of x. So what do you think the pattern will be for each of these? Here we have y equals 3x plus 1. The coefficient of x is positive 3. So what do you think the pattern will be? Well, the pattern should be going up by 3 each time. For question B, we can see that the coefficient of x is negative 1. There's an imaginary 1 here. Negative 1x. So the pattern should be is going down by 1 because it's negative. Why don't you pause the video and have a go with C, D, E, and F by yourself and see if you can tell me what the pattern will be for each of these questions. Okay, so here are my answers for C, D, E, and F. We can see that the coefficient of x is a positive 2, so the pattern should be that it's going up by 2 because it's positive, it's going up. For question D, the coefficient of x is negative half. Because it's negative, it has to be going down by half each time. Question E, the coefficient of x is 3/4. Because it's positive, the pattern will be going up by 3/4 each time. And for F, the coefficient of x is minus 5/6. Because the coefficient is negative, the pattern will be going down 5/6 each time x goes up by 1. Okay, let's have a look at these questions here. What number will be the coefficient of x for the following tables of values? So we need to ask ourselves, what is the pattern? Well, here you can see the pattern is that it's going up by 2. That means the coefficient of x has to be a positive 2. So it's going to be y equals 2x plus something or minus something. Okay, it really depends. But the important thing so far is that the number in front of x, the coefficient of x, is 2. Why don't you pause the video and have a go at question B, C, and D by yourselves. Okay, let's have a look at these. Looks like these are going down by 3 each time. So we're going to have y is equal to minus 3x plus something or minus something. We'll work on that later. The important thing is the number in front of x is minus 3, so we're going to write a minus 3 there. Okay, question C and D. Pattern here looks like it's going up by 7. So we're going to have y is equal to 7x plus something, oops, or minus something. But we know it's positive 7. We don't need to write a plus sign in front of it. We should know that it's positive if we don't write a minus sign in front of it. And for question D, it looks like it's going down by 2.5 each time. So the coefficient of x will be minus 2.5x. Okay, so the coefficient is minus 2.5. So our rule will be y equals minus 2.5x plus something. All right. Let's have a look at how to find a rule from a table of values. In order for us to do this, we need two things. We need the coefficient of x, which is what we've just worked out how to do. But we also need the y-intercept. Now the y-intercept is what y is equal to when x is 0. So we're going to look at the table of values, see what y is equal to when x is 0, and then we'll just put that in. If there is no x equals 0 in the table of values, then we need to substitute any point from the table of values, use algebra, and determine the y-intercept. We will go through that. So let's have a look at some examples. We're going to write the rule for each of the table of values above. So I'm going to scroll back up. Here's A, B, C, and D. What is the y-intercept when x is equal to 0? Well, when x is equal to 0, y is equal to positive 9. So we write our plus 9. Question B. When x is equal to 0, y is equal to 25, a positive number. So y is equal to minus 3x plus 25. If this was a negative number, we will put a minus sign here instead of a plus. But it's positive, so we'll leave it as a plus 25. Can I get you to pause the video and have a go with questions C and D? Okay, question C, when x is equal to 0, y is equal to negative 13. So here, we've got y equals 7x, but instead of writing plus, we're going to write minus 13. For question D, when x is equal to 0, y is equal to 1. A positive number, so we'll write plus 1. Okay. We're going to have a look at a couple of examples now where we don't have x equals 0 in the table of values. What do we do? So for part 1, we've got 1, 5, 2, 9, 3, 13, 4, 17, and 5, 21. Let's see what a pattern is. Seems like it's going up by 4 each time. So we have y equals 4x plus something. But we can't see any zeros over here. So what we're going to do is we're going to substitute. I'm going to write a letter for this something that we need to work out. I'm going to use B. And I'm going to take any of these points. I'll use 1, 5. And I'm going to substitute them into the equation that we just created. And we're going to work out what B is equal to. So we can see here that x is equal to 1. And I'm going to use y is equal to 5. So I'm going to replace y with 5 is equal to 4 times, I'm going to replace x with 1 plus b. 5 is equal to, 4 times 1 is just 4. So 5 is equal to 4 plus b. So we want to get b by itself, we need to take away 4. So 5 minus 4 is 1, 1 is equal to b. And so now that we've done that, we can see that y is equal to 4x plus, what's b? b is 1. So I used this, y equals 4x plus b, but instead of writing b, I wrote 1 because I know that b is equal to 1. Now you might be thinking, oh, why did I do that? Couldn't I have just drawn a 0 here and then just follow the pattern? What number plus 4 equals to 5? It has to be 1. Yeah, you could do that. Okay, you could do that. But let's have a look at question 2. What are you going to do there? You're not going to go back 76 times, 77 times. Alright, we are going to use our algebraic skills and substitute this in. So let's first see what the pattern is. Looks like we're going up by 3 each time. So that means y is equal to 3x plus something, I'll call that b. I'm going to use any of these points. Let's use this one. It doesn't matter which one you use, you get the same answer. So y is equal to 7, according to this, y is 7. We've got 3 times x is 80. And then we'll write plus b. So 7 is equal to 3 times 80, that's 240, plus b. And if I want to get b by itself, I need to get rid of this by minusing 240. And 7 minus 240 is negative 233. So let's prove that using our calculator. 7 minus 240, yep, negative 233. And therefore, my equation of line, I'm going to write the same thing here, except instead of writing b, I'm going to be writing minus 233. Y is equal to 3x minus 233. And that's the equation of the rule for the table of values for part 2. Okay. What about finding the rule from a graph? So here we've got a graph. What I want you to do is create a table of values with the numbers given to us, with the points given to us. Now it looks like we've got 1, 2, 3, and 4 points given to us. So the first one is when x is minus 2. Okay, when x is minus 2. The next one is when x is minus 1, when x is 0, and then when x is 1. Okay, so minus 2, minus 1, 0, and 1. Well, what are the y values? When x is minus 2, y is minus 1. When x is minus 1, y is 0. When x is 0, y is 1. When x is 1, y is 2. Okay, so we can see as x increases by 1, what's the pattern of these ones? They're going up by 1 as well. So the equation of this will be y equals, the number in front of x will be positive 1. But we never need to write that. There's always an imaginary 1 there. And then we need to look at the y-intercept when x is equal to 0. y is equal to 1. Positive 1. By the way, if you're wondering what y-intercept means, the y-intercept is where the line crosses the y-axis. So here we have our y-axis. Where does the line cross it? At this point. At 1. Positive 1. And that's it. Okay, so that's our rule for that graph. Okay, let's have a look at the last part of today's lesson, finding the rule from a pictorial pattern. So Jeffrey is tiling the floor in his bathroom. He has decided to use blue and white tiles in the following pattern. Construct a table of values and determine the rule for the pattern above. Now, instead of using x's and y's, we're going to use probably B and W, B for blue and W for white. So I'm going to construct a table of values, B for blue and W for white. And we only have 3 numbers here, or 3 pictures. So if there's 1 blue tile, how many white tiles are there? 1, 2, 3, 4. Alright, can I pause the video and complete this table of values? See if you can also determine the rule for the pattern. Okay, let's complete this table of values. We've got 2 blue is 6 white. If there were 3 blue, how many white would there be? 6 plus 2, that's 8. Alright, so we finished constructing the table of values. Let's see what the rule is. Well, for every 1 we go up for blue. What's happening over here? We're going up by 2. So it looks like, you know how we normally do y equals something x plus something? Normally we have x here and y down here. So instead of writing y, we're going to be writing w. The number of white tiles is equal to what number is going to go in front of x, or in this case in front of b? Positive 2. Plus, okay, what is the y-intercept? Well, we don't know that, right? There's no 0 here for us to try and figure this one out. So what we could do is we could just draw that in here, put a 0 there, and think about, alright, well, what number plus 2 equals to 4? It has to be 2. Now that's nice and easy because 0 is just before 1, right? But we couldn't do that up here. For this one, we can't put a 0 in here because we can't plus 1. It will be 1, not 77. But each of these other ones is plus 1. So we can't do, we can do it in this case right here because it's nice and easy. So that means the rule is 2b plus 2. The number of white tiles needed is 2 times the number of blue tiles needed plus 2. Alright, so we can double check this to make sure that the rule works. There's 1 blue tile in this one. So 2 times 1 is 2, plus 2 is 4. We need 4 white tiles. 1, 2, 3, 4. Good. Well, we can double check it with this one. There are 2 blue tiles, so 2 times 2 is 4, plus 2 is 6. This is saying we need 6 white tiles. Yep, there are 6 white tiles there. Okay, and it's going to work for the last one as well. Alright, let's have a look at question B. How many white tiles are required if there are 11 blue tiles? So now that we've written this formula, this equation, this rule, W is equal to 2b plus 2, we can solve problems like question B. How many white tiles are required if there are 11 blue tiles? So white is equal to 2 times b, or 11 blue tiles, plus 2. 2 times 11 is 22, and 22 plus 2 is 24. So we can say, therefore, 24 white tiles are required. Okay, last question. Question C, how many blue tiles would there be if there were 36 white tiles? So I'm going to write the formula again, the rule. And this time it says that there are 36 white tiles. So the question is, where am I going to write that 36? Am I going to replace W with it? Or am I going to replace B with it? Well, this is white tiles. So I'm going to replace W with 36. Now all we need to do is use algebra to solve this. I'm going to subtract 2 from both sides. That gives me 34 is equal to 2b. And then I'm going to divide both sides by 2 to get b by itself. 34 divided by 2 is 17. So therefore, there will be 17 blue tiles. Okay, if there were 36 white tiles. Alright, so that's it for this lesson. You should now know how to find the rule from a table of values, from a graph, and from a pictorial diagram or pattern. Okay, that's it. Thanks.